Batteries. The things you put in most batteries are pretty important to today's society. We put them in things from toys to your iPhone, which deletes in like half a second. Batteries are a not so simple process of galvanic cells, redox reactions, zinc sulfate, and manganese oxide. Let's start with a typical redox reaction in a normal everyday battery. First, elemental zinc is going to react with manganese dioxide. To produce manganese 3 oxide and zinc oxide, you have to break these down into half reactions. First, you have elemental zinc and an oxidation number of 0 begin to get oxidized by zinc 2 ions. At the same time, manganese 4 is being reduced to manganese 3. When we balance these half reactions, we see that 2 electrons are being released during the oxidation of each zinc atom, and 1 electron is consumed by each manganese 4 atom. The water and hydroxide ions, by the way, come from a solution of potassium hydroxide, which is a basic or alkaline compound, which is why we call lots of batteries alkaline batteries. I want a dog like that. I've never had a dog that fetches and brings it back. These half reactions are very important to the everyday battery. Inside the battery, we isolate each half reaction. So that on one side, excess electrons build up in the negative terminal, while on the other side, an electron vacuum of sorts builds up called the anode.
Alright, now let's move on to galvanic cells. Now, alkaline batteries, which is like the most common batteries which we use in almost everyday products, are galvanic cells. It generates electrical energy from the redox reaction. An example of this would be wires connect to 2 metal rods that are suspended in a solution. Now, one rod is known as the anode and the other one is known as the cathode. Now, what happens during this reaction is that the anode oxidizes, in which it loses the metal ions. The metal ions are accepted by the cathode rod. Well, the opposite happens with cathode rods. Cathode rods, the metal ions are accepted, and they create pure metal on the rod itself, gradually growing. The circuit is completed by a wire, which is also a salt bridge, U-shaped tube, that contains metal ions, which is allowed to go through the salt.
Voltage is an important part of the battery, but since this is not big enough to warrant its own section, I will cover it briefly. Voltage is really the way of expressing the electrical potential for each half reaction. The difference between the chemical demand for electrons is 1/2 versus the tendency to lose them in the other. Right now, I'm going to talk about some interesting conductors. A human body, as you know, is a conductor. You can obviously see this through games like GTA 5 and the car battery torture scene. We're not allowed to show you this, but many of you know what we're talking about. Metals make good conductors because their outer electrons are loose, allowing voltage to flow right through. Some materials have all their electrons closely fitted. These are called insulators, the opposite of a conductor. Conductors are all around you, including the human body, like said before, metals, and even some... Okay.
Come on, Angel.
Conductors are very important to the battery process.
Look at it.
Conductors are very important to the battery process, as without conductors, the battery would be useless in an appliance, such as a toy. Without the conductors for the cathode and anode, the circuit would not be able to be completed, thus allowing no work to be done. The first battery was created when Galvani and Volta both were in a competition on how animal electricity worked. There was a long and heated debate, but the debate was finally realized when Volta put stacked copper and zinc together, separated by a line of paper or cloth. What happened was he created the first ever oxidation reaction, in which electrons built up and switched over onto the other side. Volta did not know that the reaction was happening in the solution, not in the metals. And this is how the first battery was ever created, and is truly a miraculous and pretty ahead of its time invention.
Now let's talk about one of the most common batteries found in electronics and in cars. It is the lithium battery. The lithium battery was invented in 1980 by John Goodenough. Better batteries have been found than the lithium battery, but now the lithium battery is so mainstream that it is much cheaper to keep on advancing the lithium battery than to invest into a whole new other battery. Graphene batteries are looked to be changing that. As soon as we are able to figure out how to make graphene cheaply and effectively, that is when we will be able to create graphene batteries.
We get a weakness. You gotta see this. Yeah. Hey, I remember syrup sandwiches and crime allowances. Finesse a nigga with some counterfeits, but now